Aluminium foil, often referred to with the misnomer tin foil, is aluminium prepared in thin metal leaves with a thickness less than 0.2 mm. Thinner gauges down to 6 micrometers are also commonly used. In the United States, foils are commonly gauged in thousandths of an inch. Mils.Standard household foil is typically 0.016 mm thick, and heavy-duty household foil is typically 0.024 mm. The foil is pliable, and can be readily bent or wrapped around objects. Thin foils are fragile and are sometimes laminated to other materials such as plastics or paper to make them more useful. Aluminium foil supplanted tin foil in the mid-20th century. Annual production of aluminium foil was approximately 800,000 tons in Europe and 600,000 tons in the US. In 2003, approximately 75% of aluminium foil is used for packaging of foods, cosmetics, and chemical products, and 25% used for industrial applications. It can be recycled. In North America, aluminium foil is known as aluminum foil. It was popularized by Ronald Metals, the leading manufacturer in North America. In the United Kingdom and United States, it is informally, widely called tin foil for historical reasons. Metallized films are sometimes mistaken for aluminium foil, but are actually polymer films coated with a thin layer of aluminium. In Australia, aluminium foil is widely called alfoil. History. Before aluminium foil made from a thin leaf of tin was commercially available before its aluminium counterpart. Tin foil was marketed commercially from the late 19th into the early 20th century. The term tin foil survives in the English language as a term for the newer aluminium foil. Tin foil is less malleable than aluminium foil and tends to give a slight taste to food wrapped in it. Tin foil has been supplanted by aluminium and other materials for wrapping food. The first audio recordings on phonograph cylinders were made on tin foil. The first aluminium foil. Tin was first replaced by aluminium in 1910, when the first aluminium foil rolling plant, Dr. Laber near Amp, CIE, was opened in Emmershofen, Switzerland. The plant, owned by J.G. near Amp Sons, the aluminium manufacturers, started in 1886 in Schaffhausen, Switzerland, at the foot of the Rhine Falls, capturing the fall's energy to produce aluminium. Near's Sons, together with Dr. Laber, discovered the endless rolling process and the use of aluminium foil as a protective barrier in December 1907. In 1911, Bern-based Tobler began wrapping its chocolate bars in aluminium foil, including the unique triangular chocolate bar Tobler owned. By 1912, aluminium foil was being used by Maggi to pack soups and stock cubes. The first use of foil in the United States was in 1913 for wrapping lifesavers, candy bars, and gum. Processes evolved over time to include the use of print, color, lacquer, laminate, and the embossing of the aluminium. Manufacture. Aluminium foil is produced by rolling sheet ingots cast from molten billet aluminium, then re-rolling on sheet and foil rolling mills to the desired thickness, or by continuously casting and cold rolling. To maintain a constant thickness in aluminium foil production, beta radiation is passed through the foil to a sensor on the other side. If the intensity becomes too high, then the rollers adjust, increasing the thickness. If the intensities become too low and the foil has become too thick, the rollers apply more pressure, causing the foil to be made thinner. The continuous casting method is much less energy-intensive and has become the preferred process for thicknesses below 0.025 mm. Two layers are usually put together for the final pass and afterwards separated, which produces foil with one bright side and one matte side. The two sides in contact with each other are matte and the exterior sides become bright. This is done to reduce tearing, increase production rates, control thickness, and get around the need for a smaller diameter roller. Some lubrication is needed during the rolling stages, otherwise the foil surface can become marked with a herringbone pattern. These lubricants are sprayed on the foil surface before passing through the mill rolls. Kerosene-based lubricants are commonly used, although oils approved for food contact must be used for foil intended for food packaging. Aluminium becomes work-hardened during the cold rolling process and is annealed for most purposes. The rolls of foil are heated until the degree of softness is reached, which may be up to 340 degrees Celsius for 12 hours. During this heating, the lubricating oils are burned off, leaving a dry surface. Lubricant oils may not be completely burnt off for hard temper rolls, which can make subsequent coating or printing more difficult. The rolls of aluminium foil are then slit on slittery rewinding machines into smaller rolls. Roll slitting and rewinding is an essential part of the finishing process. Properties: aluminium foils thicker than 25 micrometers are impermeable to oxygen and water. Foils thinner than this become slightly permeable due to minute pinholes caused by the production process. Aluminium foil has a shiny side and a matte side. The shiny side is produced when the aluminium is rolled during the final pass. It is difficult to produce rollers with a gap fine enough to cope with the foil gauge. Therefore, for the final pass, two sheets are rolled at the same time, doubling the thickness of the gauge at entry to the rollers. When the sheets are later separated, the inside surface is dull, and the outside surface is shiny. This difference in the finish has led to the perception that favoring a side has an effect when cooking, while many believe that the different properties keep heat out when wrapped with the shiny finish facing out, and keep heat in with the shiny finish facing inwards. The actual difference is imperceptible without instrumentation. Increased reflectivity decreases both absorption and emission of radiation. Foil may have a non-stick coating on only one side. The reflectivity of bright aluminium foil is 88%, while dull embossed foil is about 80%. Uses: packaging: aluminium is used for packaging as it is highly malleable and can be easily converted to thin sheets and can be easily folded, rolled and packed. Aluminium foil acts as a total barrier to light and oxygen, odors and flavors, moistness, and germs, and so it is used broadly in food and pharmaceutical packaging. The purpose of aluminium is to make long-life packs for drinks and dairy goods, which allows storing without refrigeration. Aluminium foil containers and trays are used to bake pies and to pack takeaway meals, ready snacks and long-life pet foods. Aluminium foil is widely sold into the consumer market, often in rolls of 500 mm width and several meters in length. It is used for wrapping food in order to preserve it, for example, when storing leftover food in a refrigerator, when taking sandwiches on a journey, or when selling some kinds of takeaway of fast food. Tex-Mex restaurants in the United States, for example, typically provide takeaway burritos wrapped in aluminium foil. Insulation: aluminium foil is widely used for radiation shield, heat exchangers and cable liners. Aluminium foil's heat-conductive qualities make it a common accessory in hookah smoking. A sheet of perforated aluminium foil is frequently placed between the coal and the tobacco, allowing the tobacco to be heated without coming into direct contact with the burning coal. Electromagnetic shielding. The shielding effectiveness of aluminium foil depends upon the type of incident field, the thickness of the foil, and the frequency. Shielding effectiveness is usually broken down into a reflection loss and an absorption loss. Although aluminium is non-magnetic, it is a good conductor, so even a thin sheet reflects almost all of an incident electric wave. At frequencies more than 100 MHz, the electric field is attenuated by more than 80 decibels. Thin sheets of aluminium are not very effective at attenuating low-frequency magnetic fields. The shielding effectiveness is dependent upon the skin depth. A field traveling through one skin depth will lose about 63% of its energy. Thin shields also have internal reflections that reduce the shielding effectiveness. For effective shielding from a magnetic field, the shield should be several skin depths thick. Aluminium foil is about 1 mil. A thickness of 10 mils offers less than 1 decibel of shielding at 1 kHz, about 8 decibels at 10 kHz, and about 25 decibels at 100 kHz. Cooking aluminium foil is also used for barbecuing more delicate foods, such as mushrooms and vegetables. Using this method, sometimes called a hobo pack, food is wrapped in foil, then placed on the grill, preventing loss of moisture that may result in a less appealing texture. As is the case with all metallic items, aluminium foil reacts to being placed in a microwave oven. This is because of the electromagnetic fields of the microwaves inducing electric currents in the foil and high potentials at the sharp points of the foil sheet. If the potential is sufficiently high, it will cause electric arcing to areas with lower potential, even to the air surrounding the sheet. Modern microwave ovens have been designed to prevent damage to the cavity magnetron tube from microwave energy reflection, and aluminium packages designed for microwave heating are available. Art and decoration. Heavier foils made of aluminium are used for art, decoration, and crafts, especially in bright metallic colors. Metallic aluminium, normally silvery in color, can be made to take on other colors through anodization. Anodizing creates an oxide layer on the aluminium surface that can accept colored dyes or metallic salts, depending on the process used. In this way, aluminium is used to create an inexpensive gold foil that actually contains no gold, and many other bright metallic colors. These foils are sometimes used in distinctive packaging. Geochemical sampling. Foil is used by organic petroleum geochemists for protecting rock samples taken from the fields and in the labs where the sample is subject to biomarker analysis, while plastic or cloth bags are normally used for a geological sampling exercise. Cloth bags are permeable and may allow organic solvents or oils to taint the sample, and traces of the plastics from plastic bags may also taint the sample. Foil provides a seal to the ingress of organic solvents and does not taint the sample. Foil is also used extensively in geochemical laboratories to provide a barrier for the geochemist, and for sample storage. Ribbon microphones. The material used in many ribbon microphones is aluminium leaf, or imitation silver leaf, as it is sometimes called. This is pure aluminium and is around 0.6 to 2.0 micrometers thick. It is virtually the same material that the BBC used on Cole's ribbons, with the exception that they also hand-beat the leaf even thinner. They did this by sandwiching the ribbon between toilet paper and beating with a ball-peen hammer. This cold forges the leaf. The aluminium leaf was then annealed for an hour in an oven to restore flexibility. Corrugations must also be imparted into the ribbon. Coles used 25 per inch. RCA44BX has 19 corrugations per inch and is around 50 mm long. RCA77 has 13 corrugations per inch. RCA ribbon material is around 1 to 1.5 micrometers thick. The new Nady ribbon plus AEA both state that they use 2 micrometers aluminium ribbon in the microphones. Environmental issues. Some aluminium foil products can be recycled at around 5% of the original energy cost, although many aluminium laminates are not recycled due to difficulties in separating the components and low yield of aluminium metal.